And I'm making myself here.
Okay, and I guess I can start. So again, welcome everyone. This is Inspecting Existing Dwellings, the second webinar. The next one will be next Tuesday and the following Thursday. I was telling everybody there was a typo in one of my slide presentations in which it indicated it was Wednesday, which was incorrect. But just to start, before I basically start sharing my screen shortly, I wanted to do just kind of a quick caption of what we looked at in the very first webinar. So we basically talked about an introduction to the course and what to expect. So for example, next week we're going to be dealing with the next Tuesday, Thursday topics will be on the structures. But just to kind of give you a caption and highlight some of maybe the key points, I just jotted a few notes down here to think about, well, what did we really talk about in that first webinar? There was a lot of information. So we talked about building science. So building science is the study of building materials and construction and the consideration of the factors including the impact of temperature, air, water, and moisture. Those are kind of the things we don't always think about. I mean, certainly we recognize temperature, it's hot or cold. The air we take for granted, I guess. The water and the moisture and the impact of that on the building structure. So that's a lot about building science, is looking at we'll call it the physics or dynamics of the materials in the way things are built. We also covered the topic of looking at the house as a system. So that's been around since probably, I'll say the mid-'80s, looking at the house as a system. So when we build homes or houses and or any buildings, we really need to think about it with its interconnected parts. So if you take a look at these kind of the structure of the course and the webinars, it's really one system built upon multiple systems. So we take the house, we say, okay, there's the outer building envelope, so the outer skin or outer finishes that we see from the outside. And then when we start looking inside, we start thinking about, you know, the plumbing, the heating, the electrical, obviously the structure that holds the house up, and so on. So we have to think of those systems and how they're really interconnected. And the house as a system takes the approach that when we make a change to one thing, I used one example such as windows, taking the old windows out and replacing new, let's say more energy efficient windows, we might find that the building conditions change internally, because now when we look at the house, these newer windows being more energy efficient, it's going to save energy. But at the same time, we might find that those windows start to cause condensation to occur that the old windows didn't happen to exhibit. The other thing we talked about is the building codes in Canada have called for tightening up of the building envelope, the outer shell of the house again. But along with that, there was a benefit, but there's also a trade-off. So we're going to save some energy on the heating side of things, but also when we seal it up too well, we're also really not allowing air to enter into the house as freely through cracks and crevices created through the construction process. So we sealed it up so well that now we kind of created an internal environment of which it's going to trap things better within the house. Things such as moisture. So every time we cook, bathe, do laundry, etc., we're generating moisture. I mean, even people within the house, the structure itself, there's going to be a certain amount of moisture created, even in the process of us breathing. The plants. Someone mentioned, what do you think about plants? Well, I think plants are great, but also they can also generate, certainly when we keep them watered, to keep them healthy, we're probably adding more water into the internal side of the house again. So we also have to think about what's the impact of this moisture inside the house? In fact, how is it going to impact the building structure itself? Well, we know some of the worst case scenarios. We use the word M for mold. We have mold issues. And mold can be caused by a number of things, but certainly moisture accumulation that can't escape without proper ventilation is a whole huge issue in housing. And it's just not your housing, it's basically almost in mold, almost to some degree in all housing, all buildings. Let's face it, there's spores in the air that can come from the outside in and be created on the inside. And I'm not going to say they're trying to escape out, but certainly we can see the residue as mold on certain parts of the house itself. So we look at not just the mold as being part of the problem with this well-sealed house structure that we're trying to create, but we also see the potential for it to cause damage to the structural framing system itself. So most houses being built of wood, if that moisture travels into the exterior wall structure, we now have an opportunity for wood to rot and or deteriorate. The other thing we also did, we also looked at a few photographs of some conditions, and we're going to be taking a look at a few more. So that's just sort of a real quick overview of what we talked about in webinar 1, without getting into, we'll call it tons of reading that we've passed on to you. So now I'm going to try and share my screen. Where did I put it? Building science. And I'm going to have to find where we left off here. My apologies. It's this slide. So as we can see here, I think we stopped at roughly this slide, or pretty close to it. So we looked at some of the issues, and certainly there are other influences when we talk about building science. So we talked about moisture, we talked about air, we talked about water entry. Certainly in this slide we can see other things we need to think about is how much rain do we get, which is, again, something that's addressed in the building codes, is how should we address issues such as rain. Should we have eaves troughs on a house or not? How does the wind impact our environment as far as where you're located, which gets us down to latitude, and also we start looking at, you know, the sort of the orientation to the south, ideally to gain heat, and reducing the amount of openings on the north to reduce the cold influence of heat loss on the north side. But let's face it, in the ideal world, not every house is built to a north-south orientation. So we also talked about the house as a system. And again, just as a reminder, when I show the slide here, often you'll see down in the lower corner, you'll notice HB, which is your handbook or your course notes. This is referenced on pages 21 and 22. So it's just kind of a little guide if you happen to be looking at this later and you're reading through your notes. It's kind of a interrelationship between the slide presentation and the notes that you have. So as I mentioned, the home has a series of interrelated parts, and changing one without consideration of the others can create a domino effect, and worst case, with negative outcomes. So as we can see, it became apparent when the building industry increased the envelope tightness, which was, again, a building code thing, and trying to create better energy efficiency and less heat loss out of the house. What they really did is they created this sort of almost, we'll call it, well, almost like an airtight baggie in a way. So it decreased the home's performance and air quality, and also the ability to control the moisture that's potentially trapped within that building envelope. So homes built tighter equal basically indoor air quality issues, therefore a decrease in air quality and issues with moisture cropped up. And I mentioned the words mold and or also deterioration of the wood frame structure itself, with the moisture basically impacting and basically causing water damage to the wood. So to counter the problems with moisture and water, it must be kept out of the structure. We also need to think of how can we get the moisture out. So as an example, in my home, when I built it, I initially did not have a heat recovery ventilation system. I had some exhaust fans in the bathroom. I didn't have an exhaust fan in my laundry room or even in my kitchen. But those things certainly do help. But I also, over time, discovered that I was getting a lot of condensation and moisture buildup in the house, which means I need to really think about a heat recovery ventilation system, or an ERV, energy recovery ventilation system. In other words, more of a whole house approach to ventilating my house, getting the moisture out, because I started to see the initial signs of mold developing in some of the closets. So in order to counter that, as I mentioned, ventilate spaces such as bathrooms and laundry rooms and kitchens to get air movement and an air exchange going on. Drawing fresh air in through my heating system, it's tempered, and also it's going to be heated and or capturing the heat coming back from the space in exchange in my heat recovery ventilator, we'll call it box. So my HRV's in my basement, not too far away from my forced air furnace. Well, that's one point, but I also mentioned the issue about replacing things such as windows and doors. So when we start looking at higher, better energy efficient windows and doors, although it might not be a big thing, overall there still is an impact, because with the trapped moisture, obviously in the cold temperatures or cooler temperatures, we can see the buildup of condensation on the inside of the window. Now, if this was the old farmhouse that I initially lived in when my wife and I first got married that we rented, it was so air leakage, we had to fight to try and keep heat. And certainly it was well ventilated because of the poor construction at the time. So again, you know, we look at the house as a system. So the house as a system continued. So approach and see the house as the total environment made up of the building envelope plus all the contents. So the building envelope defines the separation of the indoor space from the outdoor space. I like to call it that outer shell or skin of the building. The contents are made up of the occupants and the mechanical systems. So basically, a house equals a building envelope plus the people living in it. And certainly the more people we have living in it, the more opportunity for moisture to be generated within that. Maybe with more people, certainly more showers, more baths, more cooking, etc., more moisture generation. Well, the contents certainly are the people. Well, we can't control always the amount of people in our home. You know, and we also have to think about things such as the mechanical system. So what type of mechanical system do we have? I mentioned, for example, my mechanical system is a forced air furnace with a heat recovery ventilation system. But I also have a plumbing system, and you know, plumbing systems are not foolproof either. You know, I can get water. I can get water to boil or cook. But I also can have leaks occur within the building structure because of the plumbing, if it's not properly maintained. So these elements, together with the outdoor climate and soil conditions, if we think about the outdoors now, the changes of temperature and the soil conditions. Do we have a lot of groundwater? Are we located in a place where we're high and dry, so to speak, as opposed to low and potentially wet? And certainly we have to consider when we look at our proximity to large bodies of water, how much groundwater do we have around our house? So these interplay with the key characteristics of the air, the heat, and the moisture that we talked about last time. So again, the system approach accepts the principle that the various components and systems do not work separately. Many of them work together. Vital need for proper consideration to the effects of each on the components in a home to maximize the energy efficiency, which is potentially a goal, but also for the comfort, durability, and the air quality and affordability of looking at the house. Well, we talked a little bit about, air quality, and we have to think about things such as healthy housing. And it's based on research exploring the issues of environmental and economically sound design development, supporting on 5 basic fundamental principles. As we can see here, the occupant health, energy efficiency, resource efficiency, environmental responsibility, and affordability. And again, these are basically the healthy housing concept taken from Camden Mortgage Housing Corporation. I also teach courses on mold and indoor air quality, but that's a whole other side issue for another time. So occupant health. So I'll let you read here about indoor air quality, water quality, light, sound, and radiation. First 3 of those points. I'll just give you a few minutes there to take a look at that slide rather than me just reading it to you.
One of the issues that have been raised is COVID-19 and indoor air quality issues and change in filters. And so in the upcoming podcast, we actually have a podcast on the impact of COVID-19 in homes in terms of ventilation. So that should be out in, I'm hoping, end of probably November 1 by the time they're aired on the radio stations. And we will share that with everybody as well.
Thanks, John. Okay, I'll move on to the next slide here. So the energy efficiency equation. So we look at building thermal performance, energy for the heating, cooling, and ventilation systems. And again, maybe not all houses have cooling. It maybe cooling is just simply opening the windows or doors. How about renewable energy? Again, we talked about solar gains slightly in the placement of windows to capture these solar gains. Ideally, from my architectural background, large windows facing south, smaller windows facing north to reduce heat loss through those windows. And electrical consumption. And peak demand, well, the peak demand means that when there's a large demand for electrical power close to all the shops and businesses close to where I live, if I'm on when they're on, I'm going to pay more for my electrical bill than if I use it when it's sort of off-peak period. So again, it depends on where you live in the way you are billed for example, electrical. So again, having an effect on the efficiency from the energy point of view. How about resource efficiency? So again, we look at things such as embodied energy, the selection of renewable, recyclable, or reused materials where possible. Management of construction waste. Well, more waste to the dump means maybe we should think about how do we reduce waste in general. And water, okay, water efficient plumbing fixtures. Again, all of these things have an impact on the house and the house as a system, and certainly on the issue of building science when we look at it from a more global perspective. And of course, the materials, durability and longevity. Are we building with good, solid, long-lasting building materials? There's the environmental responsibility portion. So the emissions and combustions of byproducts. Again, when we take a look at some of the things such as, we'll call it even the kitchen cabinets, the glues, the materials used to create the wood itself, sometimes those certainly have an impact and will off gas, causing other issues of indoor air quality. How do we deal with wastewater and sewage? And of course, hopefully, if you have some community planning and site planning issues, hopefully people that are looking at planning and the site planning perspective are trying to make sure that we don't have, we'll say, the factory next to your house or something that might be detrimental to your housing in general. Hazardous materials. Okay, the avoidance of hazardous materials during construction. Again, in the past, we could talk about issues such as asbestos. Another issue we talked about a little bit is radon. Radon in the soil. So sometimes it's a colorless, odorless gas that maybe we're building on top of an area where radon can impact the living conditions and the people within the house or the building. And of course, affordability. Affordability is always a big issue because we always want to build for the most practical price, but also affordability is also how much can we get, how many new homes can we get, so everybody has a right to get a house to live in. Viability for construction industry, reliance on simple technologies. Again, not all things that we get in Canada are suitable for Canadian climates. So as an example, heat pumps were really good in the south of the US, but until more recent times, heat pumps were questionable for use in, let's say, northern climates. Now, those are being addressed by the industry itself by trying to make things more suitable for those climates. Adaptability. Again, is the way we build things, is it really the best for your particular, let's say, community or environment? And marketability, catering to the real needs of people. Okay, so what is the consumer perception about housing in general? So just some things to think about. I skipped over energy guide because we're going to talk about that more later. So there are some actual slides in here I just kind of skipped over very quickly. So energy advisors. So energy advisors are basically similar to inspectors. They gather information based on the house and the physical inspection of the house. And it has to do with energy efficiency. So what we would consider doing the blower door test. And someone was asking before is how do we check air pressure in a home? And this is what energy advisors actually do. So the building envelope's air tightness and thermal resistance are what they're looking for. They're looking at the characteristics of the heating system and what type of water system, as we looked at things such as the mentioning of energy efficient fixtures and so on. The ventilation system, so they're going to determine flow rates, including exhaust fans, particularly for areas such as kitchens, bathrooms, and probably even laundry rooms. And looking at renewable energy equipment that is permanently installed, such as a solar domestic water heater or ground source heat pumps. So again, the energy guide review, that's a whole other side of inspection that some specialist energy advisors perform. So we also, looking at the issue of air quality, have to look at the combustion, particularly of fuel-fired appliances in our house. So we're going to look at ventilation, air quality, and combustion spillage. If we take a look at the picture, you'll notice the difference in the color of the flame. So myself, with my home inspection or my inspection background, when I look at the flame color, I can see here over to the left, it has a little bit of blue, getting closer to normal. In the middle, it's a little variation, but to the far right, I see a lot of yellow. To me, that's a furnace that needs to be basically looked at by a professional licensed heating contractor, because that is going to show me signs that there's going to be issues with potentially carbon monoxide and or dirty fuel jets on this furnace, which could cause problems for the indoor air quality of a house. So we talked about the tighter house. So as homes are being built tighter, fresh air cannot enter as freely as they used to. New homes may need a mechanical ventilation system. So basically all building codes in Canada pretty much are requiring some type of mechanical ventilation system to bring and exchange air in a house. So something like the heat recovery ventilation system. So when we take a look at that, it's going to exhaust the stale air out, which is heated. It's going to bring fresh and even in the winter colder air in. But when the two merge in the HRV box, they basically exchange the heat that'll help temper that colder air coming into the house. So it's not extremely cold, but certainly cold air that can be tempered by the exhausted air going out. So it's a very good, efficient system. By the way, not very cheap though either. Adequate ventilation is essential in all houses to really ensure good indoor air quality. Certainly, along with it, it's taking the condensation and moisture out of the house. And also, the unit itself is going to feed basically and get into, in the case of a forced air system, it's going to create a better air quality being circulated in a house. As we know, older houses were ventilated by air leakage. That old farmhouse I lived in rather. So there were a lot of cracks and openings in the building envelope. So in recent years, there was the desire to conserve energy, which basically led to the building codes changing and requiring this type of mechanical ventilation system. So what about the products of combustion? So air is vital for the combustion process. So fuel burning appliances generate products of combustion and heat, but it also can create, in a bad condition, a negative environment, toxic gases such as carbon monoxide. It also produces acids such as sulfuric acid and nitric acid. So how do we get rid of these things? So we need some type of mechanism to basically get rid of these byproducts of combustion. So typically what we're going to have is piping going to something like our sump pump well or a floor drain to basically get rid of those. We don't want to keep them in the house. We want to get it out of the house as quickly as possible. Heat, including conduction, radiation, and convection for hot gases and flying firebrands and fumes, can also cause issues. So for example, if we take a look at fireplaces, different heating appliances. So because of the hazards of venting, exhausting fuel-fired devices, the codes require chimneys and vents to be constructed to meet minimum code standards for health and safety. So even when we take a look at the venting, proper venting on heating equipment, it's really critical for the home inspector, or the inspector rather, to look at. Getting too used to teaching home inspectors. So ventilation, removing the indoor air and replacing it with fresh outside air. For ventilation, we need both an exhaust and a fresh air supply. So we need piping or some type of ductwork. Ventilating buildings provide a healthy indoor environment, and ventilation can be either natural or mechanical. When we talk about natural, we're talking about opening the windows and or opening the doors, whereas mechanical, we're using a piece of equipment such as a fan or a heat recovery ventilation system. Again, the purpose: remove heat and moisture, get the stale air out, reduce the concentration of contaminants that's leading to poor indoor air quality. So air should be exhausted from rooms likely to have high moisture contents. Bathrooms, kitchens, laundry rooms, good examples. Fresh air should be supplied to bedrooms and living areas where people tend to spend a great deal of their time. Let's face it, I hope most people sleep at 6, 7, 8 hours. So we spend a good deal of our time, certainly in bedrooms and living spaces. Air quality. So numerous health concerns related to exposure to indoor pollutants. Certainly, we don't want people to get sick, but unfortunately it does happen. So acceptable air quality is a significant concern. So we need sufficient amounts of clean air are required to keep oxygen at an acceptable level so we don't get sick from things such as carbon monoxide. So the air must be free of odors and other pollutants. So even when we start looking at air quality, we could have products underneath our kitchen sink, such as bleaches and cleaning solutions. And sometimes if you read the labels might scare you. And certainly things such as bleach. In my laundry room, if my furnace was in that room, can deteriorate the metal on the actual heating equipment itself much quicker. So again, we have to think about it from, again, the building science point of view. Well, I guess kind of a universal way before we get into the details of the nitty-gritty of plumbing, heating, electrical, and structural. So ideal conditions can be obtained by introducing filters and outside air into the ventilation system of a house. So as we can see here in this diagram, figure 2, we have to the left-hand side, supposedly the water heater. And if it's one of the older style, we have air being diluted and being sucked up and vented, along with the combustion air being used for combustion and going up the chimney or the flue. And if any of those systems basically start to backdraft, well, basically a backdraft means it's going down back into the house, not up the chimney where it should be going. And as we indicated before in the first webinar, heat rises, and that heated air from both of those appliances, the air should be going up and out the chimney. Well, the other thing, we can bring in outside air intake. We can have a vent on the outside and bring fresh air in and basically help dump it into our crawl space or basement. The problem with that system is, what do you do in the winter? We have freezing cold air coming into our house. How do we temper it? And that's where the HRV is really the piece of equipment to go with, but certainly this system here we see in this diagram is certainly not that expensive, but it creates other issues. Pollutants are generated indoors from a number of sources, and again, I'll let you read all of these. So I'll take a peek at the slide there.
Claude, while you're reading that, there's a question from Dale. That is, where would electromagnetic shielding be needed in a house?
Oh, that's a good question. So really when we're talking electronic magnetic shielding, we're talking about really high energy source from electricity. Again, that's something I typically would look at as an inspector. How close are you to high power energy source lines, such as that, the hydro poles, not so much so close to the house, but certainly in close proximity. So that's one of the areas that really is not that well understood, but certainly Dale raises a really good question. Is we get back to the thing of sensitivity, individual sensitivity, but the actual shielding in a house, I'm not too familiar with too many systems that are out there that actually help shield, other than the issue of distance, keeping reasonable distance away from those sources of high energy electrical currents.
Claude,
Yes.
about that metal shielding, right? Okay, I'll give you some No, it's about that. We have that. Everybody has it in their home, right? You get that through when you plug in your refrigerator, your toaster, your lights, and all that. You get electromagnetic fields or electromagnetic radiation coming out from these. The best way to avoid it is to unplug them if you're not going to use them.
Really good point. Yes, I guess that's one way to shield yourself from them.
Yeah,
Yeah.
and, there's a world protest against the 5Gs. So if you have a chance to go under 5Gs, which majority of the population in the world is fortnight protesting against the governments for these 5Gs. Okay, that's pretty well everywhere on the internet right now.
Well, thank you very much for that information. I guess I just learned something new. That's good to hear.
Mhm.
Certainly. John, is there any other questions out there?
That's the only question so far.
Okay, so moving on, we see air quality. Other factors which influence indoor air quality are, again, we've touched on many of these. Okay, it's the site, weather, ventilation, infiltration, the control systems, material durability. I mentioned about furnishing, so even our carpeting and our couch might be bringing in issues of some strange smells that we never experienced before. Maintenance and deterioration of the structure, certainly mold also can cause things such as mildew, which gives a more of a, we'll say of a smell to our tingle our nose as far as air quality. And certainly there are design and human factors that we need to take into account when we talk about air quality in a house. So combustion spillage. So we've been talking a little bit about combustion spillage here, and here again is another picture, a 2002 inspection I was doing, and this is the top of a water heater. Now, number one, we'll call it the vent system here is obviously cracked and open. And number two, it's not really the ideal material for this. So the term used to describe unwanted flow of combustion gases into your home. The number of houses with potentially significant spillage is increasing, and on occasion the results can be extremely serious. As we know, people can die from carbon monoxide poisoning. Now, the good thing is this was in a crawl space. The bad news is it still can be a reasonably sealed area, of which we could still have some of those products of combustion seeping up through the floor system in a, we'll say, floor that has some open cracks, and we could have some of that spillage enter into the house. So again, a crawl space, not a good condition. So combustion spillage. Well, again, I will let you read this. So we're concerned with appliances that burn fuels. And then when we look at unvented or improperly vented appliance, can add large amounts of moisture to the air. So again, we have another device that can also contribute to a lot of moisture in a house. Here's another example of a disconnected vent. So makeup air is required in houses where exhaust appliances induce a negative pressure, which might lead to backdrafting, again, and spillage of combustion products from fuel-fired appliances. So again, these are supposed to be venting into the chimney, which is over to the right-hand side. We can see it's disconnected here. And in this basement, basically, we're going to be dumping the products of the exhaust, which is supposed to be going up into the chimney and up through the chimney to the outside. So sometimes I have to get out my, carbon monoxide detector and basically do some measurements and reading and say, by the way, the reading is getting extremely high. You might want to consider either fixing this, which it obviously could be done, just come apart. And simply, it's certainly not the best for your health living in this house. So there was a group discussion. We're going to skip over that. Okay, so I was talking about the blower door. Identify the problem or propose solution for the following slides. So when we talk about a blower door, it's basically creating a vacuum in the house, which is basically, as it depressurizes the house, it's going to basically exhaust the air out of the house, okay, the outgoing air, and it's going to measure the airflow rate and the house pressure itself. So it's going to show where all these magenta colored lines indicate, well, the leakage into the basement, where there's that connection there between the floor and the foundation, where we build the platform, on top of the platform our wall, where we build our ceiling, and so on, and attic leaks. It's going to start showing us where all the air is infiltrating through the cracks of the house. So depressurizing the house, the technicians, it helps detect the most leakage areas as well as measure the total house air leakage. What do you think? Do you think we have a lot of leakage in a house that looks like this? When we talk about the exterior building envelope, and again, this is one of the First Nation homes in Ontario, we take a look at some basically pressboard siding with a nice finish on it once upon a time that's been repainted. We see some old plywood sheathing. We see the window that's in not so great a condition. I bet you there's a lot of air leakage here. And certainly we can see there's been some water staining underneath the wood window. Certainly there's probably a lot of moisture in a house such as this. Take a look at another. Okay, we take a look at the fascia board. And we take a look at the condition of the wood framing on this window. And depending on the type of window, it's probably a window that should be upgraded. Looks like a sashless slider type, which is not very energy efficient. But when we start looking at the materials and the damage that's been caused over time, and look at the condition, certainly it gets a lot of telltale signs of moisture and water that can penetrate into the building envelope.
What's interesting in that picture, the siding looks like it's vinyl, but the fascia was just wood, or it got ripped off.
Yeah, the siding was just wood. It was just left as plain wood. The siding is actually metal. It doesn't look too bad in comparison to its age. But as you can see in a few spots, it's not very well sealed, but that's a whole other issue.
Yeah, and the windows weren't capped, or they got ripped off.
Exactly. Exterior cladding. Well, again, a house that's similar, nice new door. Watch your step going out the door, though. But aside from that, what happens to plywood, the skirting here? I understand the purpose of the skirting, but why not protect it with something so we don't have it deteriorate, and certainly we don't have water penetrating it and causing further damage. Mind you, it's only a crawl space underneath there. But again, John's right. You have to look for the flashings. Look at how well it should be. We see the trims, the proper moldings for the siding around the door or the windows. But one thing I do see that's kind of missing is the flashings. Again, flashings are meant to help deflect water away from, in this case, ice damming. Well, ice damming isn't too bad, but imagine where these sometimes go down probably halfway, if not past the windows. So this is a sign of, again, insulation and the clear ventilation over the top of this exterior wall in the actual roof attic space. And here's a real oldie. What do we do here? We have an old wood frame structure, some old mineral fiber insulation in the attic space. But if you look closely, you'll see some white areas when we look towards the left. That's daylight I see through the fascia and overhang. So areas where, well, we have lots of ventilation, but certainly it's not well sealed and so on. And certainly can cause damage, water and moisture damage to the actual, not just insulation, but to the wood frame structure itself. Here's a basement. The insulation's been removed because they are going to do some, I guess, remodeling in this particular basement. But look at the cracks in the foundation, concrete block foundation, major cracks. Maybe the wood framing itself is actually helping to stop that basement block wall from bowing. But if we take a look towards the corner, we see a lot of moisture generation that's been built up, causing the potential for moisture. Again, not well sealed around the upper part where the floor framing meets the top of the foundation wall. That should be insulated and moisture protected. Whoops. Next slide here. A heating register in a house. You think there's signs of moisture? It must be. Look at all the rust. And that's a whole other issue. This popcorn type ceiling is potentially, it could be asbestos in the ceiling finish or wall finish in this case. Another crawl space.
If we went back to that roof, the popcorn ceilings, when did they, on the asbestos issue, what years did they use asbestos for popcorn ceilings?
They were quite predominant in the 60s and 70s. And basically what it is it's a textured spray with kind of that finish. And of course, when we paint it, it gives that kind of granular, and some people like to call it the popcorn look to a ceiling or a wall. You know, so people at the time thought, well, you know, hey, asbestos is good because it's a fireproofing material. But if you want to finish things like this, certainly there's concerns because some people don't like this look. It particularly obviously would date or age the finish of a house. Crawl space. Nice use of some tree trunks and so on. Some concrete blocks, not in the proper orientation for structure. They've basically jacked up the floors here because there's been settlement. But when we take a look at things such as this crawl space, there should be, I don't mind the fact that it's kind of a sandy finish in here, but there should be a polyethylene vapor barrier covering the entire floor. It doesn't have to be taped, but it should certainly overlap to help seal the moisture migrating up into the wood structure. If you look at the wood, particularly on these piers, you'll see where there's water damage or moisture damage. And also probably the darkening of the wood is moisture that's actually penetrated up into the wood. Mind you, it might take a long time for some of these to rot totally out, but certainly with some members that are smaller in size, it would certainly deteriorate much quicker. So again, moisture and water in a house. And again, if it's going here, it can also migrate up into the floor system, which causes other problems to the floor sheathing in a house. Take a look at a ceiling condition. I don't know if somebody put their foot through the ceiling or what. But in this particular case, certainly we can see here, I can't see any signs of vapor barrier and or insulation. So again, when I look at this, I start looking at, okay, so we have some open joints that need some repairs, but I don't see any signs of moisture protection up into the attic or insulation. And I guess the game sorry applies here. Sorry. Chimney venting. When we take a look at how the vents enter into the chimney, in this case, the bottom is well sealed. The top wasn't so well sealed. You can see the open joints. Is there a chance for backdrafting to occur? The better sealed it is, less chance of a backdraft.
So in that case, you would just get a bottle of spray foam and shoot it in there.
Yeah, you could.
Because it doesn't have to be cement.
No, it doesn't have to be cement. It could nowadays it could be a spray foam. Certainly, it could be well sealed. So I had some review questions, but we're not going to talk about review questions. Certainly, you have this slide presentation. So just a quick review. Do you understand the impact of air, heat, and moisture flow through a house? So those are all critical elements. The dynamics of those forces on the building envelope. So we have things such as the wind, the climate, ground conditions, moisture in the ground, depending on the type of soil. The understanding of the concept of the house as a system. Remember, when we make a change, we also should be thinking beyond just the windows being changed. What could be the impact on other systems within the house? Will there be an impact on everything? Not always, but certainly we have to think about it and consider what could it do down the road. The effects of these on the comfort and energy efficiency, durability, quality, and affordability, and longevity of a house. I mean, it's my general understanding that it's truly unfortunate that housing in many communities on reserve don't last as long as houses off reserve. And there's a number of factors that lead to that. As certainly the number of people in the home, the amount of activities that go on and different things that happen within that house. But certainly there's a lot of good reason to build better, more efficiently, and think about things lasting for a longer period of time. And certainly we can't always afford, we'll call it the top quality of materials, but certainly there are materials out there that are still effective that don't have to cost a lot. So the choice of materials, things that will last longer that don't have to cost so much. Of course, we talk about air quality and the impact on the occupant and the occupants upon the building structure itself. Okay, that is it for this particular webinar. Any questions there, John, before we sign off?
No, I don't have any questions, but if anybody wants to have any comments or contributions, feel free to open your mics. And I know that a few people have been sending us information to share. Elvis has sent us some documents. We will share those with everybody else. So if people have good information you want to share, please do it. Darlene, go ahead.
Simon has a question.
Okay.
How old was those water heaters there with the broken ventilation system? How old was that? Do you know?
Those water heaters were probably well beyond their life expectancy, number one. Those are the old style where nowadays, if you look at induced draft, certainly that they have become more common because of, well, they're just simply more efficient than the old ones. So the efficiency of the old style that we see, that hood on top, where it's basically drawing air in from the surrounding area, no matter what that area is, it's basically using that surrounding air to basically help pressurize and blow the, we'll say, the exhaust itself up through the chimney. So what era? I still see some around. Certainly, they still exist.
I just got rid of mine 3 weeks ago, and it was 18 years old.
How old?
18.
Yeah.
I said 80s.
That's what I thought he said. I was going to say 80 years old. Boy, you got good use out of that one. Yeah, they were fairly common in certainly older homes. Certainly, the ones that I would recommend is certainly what they call the induced draft. That's the one with the fan on top. And the other factor is with induced draft, you don't necessarily need to go up a chimney. You can go out a side wall of a house or building, and they certainly are more energy efficient.
That's the hot water tanks that they're talking about. That
I'm sorry, I didn't quite hear the full question.
that is not hot water tanks that you are talking about?
Yes.
Really?
It was a hot water tank, right, Claude?
Yeah, that was which one were you referring to? The one that had the open joint on the exhaust?
Yeah, on page 18, the second
Second slide.
combustion spillage.
Okay, let me go back there a minute.
No, the one a little higher. Yeah, that one. Is that a
That
water
one.
tank?
That is a water tank.
Yeah.
Like I never seen water tanks like that.
Yeah, so
Yeah.
basically, if you look at the size, you can see it's fairly large. It's an older tank. This is in 2002. I took the picture. So it's an old water heater, and basically we see this exhaust system where it would be pulling the air, if you follow my arrow, kind of up and through, and it should be solid duct, not a coiled duct. Number one, this is a dryer vent. That this was never intended for this type of application. Of course, I can see why they did it, because look, everything's in the way.
Yeah.
Right? In fact, there's a light right there too that's kind of hanging down. So if you take a look at it, it's a horrible situation.
Mike Holmes would have heart attacks.
Mike Holmes would have nothing nice to say, certainly on that one. But that's certainly an old water heater, and there's still a few of these still in existence. Like I say, you can buy them, but they're certainly not very energy efficient. Okay. Any other questions?
What is a firebrand?
A firebrand is basically the cinders is really what we're talking about. So what I'm really talking about when we talk about firebrand is cinders.
Okay.
So if we think of the burnt material in a fireplace, that's what we're talking about.
Oh, okay. Cool.
You just say.
It's one of those Eastern Ontario words.
Working in Quebec.
Okay, I do have many more slides to show at some point in time, but what I may end up doing is sending out some of the slides with some explanations of some of the conditions. I've got hundreds of slides on topics such as this. Okay. Is there any other questions or comments before we kind of sign off here?
No.
If not, thank you very much. I hope you can keep up with your reading. I'm sure it's going to be a challenge. But if you have questions, always feel free to ask or post them in your chats. Okay, thanks again.
All right. Thanks, everyone.
Thank you. Bye. Have a good weekend.
You too.